So you should have just heard a little announcement saying that this session is being recorded. This session is being recorded, and afterwards I'll be sending a link to everybody who registered so they can watch it back. Okay, very warm welcome. Could you do me a favor? Just to test that we're being heard, and just because we'd like to ask a couple of questions, could you, in the chat, just let us know where you're joining from, if you're happy to? We're really curious to know where in the world our audience is. It's always fascinating to know where people are in the world when they're listening to us. So if you can find the chat and let us know, that'd be really good. It also helps me know that we're being heard. Somebody's joined from Saudi and somebody else from Bahrain. Very interesting. I hope you're having a good day where you are. Where we are here in the UK in the southeast, it's nice and sunny. Someone from Leicester. I hope you're not suffering too badly from the bad weather we have in the UK at the moment. So that's very interesting. Just another quick question before we get going, whilst we let people join. Could you let us know how you heard about this webinar? We're curious to know how you were invited to it, just to know what communications were getting through to people, whether it was a UCL email or a LinkedIn email, or you saw it advertised on Google. It'd be really helpful. So somebody got it through email, interesting, and somebody else through LinkedIn invitation. And somebody else from LinkedIn. Yep, quite a few people from LinkedIn. Yeah, it's something we've been working on more over the last year or so, but it's very useful because we can try and reach the people who we think would be interested in coming and study a degree with us and interested in studying in the UK and in London. So that's very helpful. Thank you for letting us know that. Very helpful indeed and very interesting. Well, wherever you are in the world, it's great to have you with us today on this UK sunny Tuesday afternoon. My name's Kim Morgan. I'm the Communications and Outreach Coordinator at UCL Biochemical Engineering, and it's great to have you here for this webinar on the Biochemical Engineering MSc here at UCL. My colleague, Dr. Petra Hanga, will talk to you about the program, and then at the end of the session, we really look forward to your questions. Just to let you know how this session is going to work, if you have any technical problems, if you can't hear us properly, if we're not coming through clearly, or there's any kind of issue with the slides, you can let myself and Petra know in the chat. So if you're on a mobile device, towards the bottom of the screen, usually, depending on the device, you'll see that there are some buttons. So you can configure how you want to see us, whether you want to see the presentation. You also have access to a chat box and a Q&A box. You can put your questions at any point in the session. We're really looking forward to them, and please post them as they occur to you. But it's really helpful if you put questions in the Q&A box. It just helps us answer them more effectively, and we're less likely to miss them. Sometimes we can get a lot of questions through. If I turn my camera off, I'll still be here in the background. If you have any issues, just let me know in the chat. I'll also let you have my email address as well, which you should already have as I've emailed you directly. But just to let you know, if you have any problems, you can always email me. And again, after the session, if there's something you want to know, you can email me directly. We're always happy to deal with it afterwards. So thank you for your patience whilst I explain all that. And over to you, Petra.
Thank you so much, Kim. Hello, everyone, and welcome to this. I am absolutely delighted that you joined us and that you're interested in learning more about our master's program in biochemical engineering here at UCL. So my name is Petra Hanga, and I'll be taking you through, all the important details about this master program. Okay, right. So as an overview of today's presentation, I'm just going to give you a very, very brief introduction to UCL. But I'm not going to focus too much on it because you're here to learn about the program rather than UCL. But then I think it's important that you do learn a few facts. Also, a little bit about our biochemical engineering department, which is within the Faculty of Engineering. I'll talk a little bit about who I am so that you get a bit of an idea, and then I'll take you through the program and essentially cover all the important bits and bobs like entry requirement, how the program is structured, What do you do? What do you learn from this program? What sort of projects will you be doing? And then some really unique aspects of training that are related to our department at UCL and also to this program. And of course, I'm sure you're all very keen to learn about where our graduate students, postgraduate students end up. So I'll have a slide on the career destinations of our students. So UCL, some of you are probably already familiar with this, but it is one of the very best universities in the world. Actually, last year we were named the University of the Year 2024. Actually, not the last year, this year. We're not in 2025 just yet, even though I know everyone's looking forward to 2025, or at least the Christmas break for sure, because it feels like it's been a long year. But this year has been named the University of the Year 2024 by the Times in the Sunday Times Good University Guide. It is this year also ranked 9th in the world, and in the UK in terms of research power, so research strength, UCL ranks 2nd. So we are a extremely good university that provides very good quality training for our students, but also loads of opportunities, especially in if you are interested in doing research after your degrees. The Department of Biochemical Engineering is quite a small department. We only have about 30 members of academic and teaching staff. We are a department within the Faculty of Engineering. And actually, we were the first department in the UK to dedicate itself to biochemical engineering research and teaching. So we have a lot of legacy in biochemical engineering. We are very research focused, the same way as UCL. So we have that research culture. So we do have a lot of doctoral students and postdoctoral researchers as well. And as a result of our strength in research, we have state-of-the-art facilities, laboratory facilities, including a pilot plant facility, which is quite unique, but it is part of what we do as biochemical engineers. And of course, because biochemical engineering is essentially translatable, it is all about making products that are useful and bringing those from the lab to the industrial scale so that they become available. We have a lot of links with industry, and a lot of the projects that we do within the department are industrial collaborations. Okay, so enough about UCL and the department. Just a little bit about myself so that you know who I am. I am currently an associate professor in the Department of Biochemical Engineering at UCL. I actually started at UCL in September 2021, so I haven't been around at UCL for a very long time. But since I started, I've also been the program director and the admissions tutor on the MSc in biochemical engineering. And I am a biochemical engineer by training. So as you can see in my resume, pretty much everything I've done has been along these lines of research and development in biochemical engineering. And that's my email address if you want to reach out to me at a later point, or if you have any questions that you want to ask after this session, you're very, very welcome to reach out. Right, so the MSc in Biochemical Engineering program, sorry, I thought I muted myself, but no, I'm all good. It is, as the name suggests, it is focused on biochemical engineering principles, and is all about learning everything you need to know in order to translate those developments, those research elements from the lab scale into industrial scale so that those products become commercially available and essentially reach the people that actually need them. So what you will be learning through this program is all about engineering skills. So you will learn all those advanced engineering skills, anything from bioprocess design to bioreactor engineering. You'll also be learning about various state-of-the-art techniques and all the developments in life science that we apply as biochemical engineers in developing these bioprocesses. There will be modules that are focused on molecular biology, vaccine development, microfluidics. And of course, we value very much working with industry, and we value very much all the traits that are required in order to make these real products, available products. So there will be elements that cover regulatory knowledge, elements that will give you an opportunity to learn a bit more about how commercialization of these type of products can be achieved. And of course, management and quality control, those are parts, essential parts in manufacturing. So you will have modules that will teach you everything you need to know about those aspects. And this program, you know, it might sound, I don't know, very nice and, I don't know, very, I don't know what the word is, but anyway, the program is very unique, and I'm not exaggerating it in any way. It is unique because of the way it is structured, and it is unique because it is translational. So everything we do as biochemical engineers is translational, which means that there are a lot of links with industry. So I've mentioned it is unique because of the way it is structured. And this is because this is the only engineering program that will actually accept graduates from a science degree. So we cater for both scientists and also engineers graduates through the structure of this program, in the sense that we have two separate routes. And the idea is that both graduates from science or from engineering will learn the necessary skills and knowledge that will allow them to work in bioprocessing. And you will see that when we talk about the curriculum, the detailed curriculum per route in the next couple of slides. This program is also unique because, as I mentioned, it is translational. So we do work with the industry quite a lot. And actually our department has established some years ago very unique industrial training courses, which are called the MBI courses, or modular training for the bioprocess industries. And through this program, this MSc program, you actually get access to that. I have a separate slide on that, but just to give you an idea of what that actually means, those courses are trained together with industrialists, and they are delivered by people from industry and also people from academia, from our department. But essentially it gives you the opportunity to sit together with people, scientists from industry, and learn the same material. It's an opportunity for you to actually make connections and extend your network, and who knows, find your future employer. And also this program is one of the very few programs that are accredited by a professional body, which is the Institution of Chemical Engineers, the ICHEME. Right, so what does this accreditation mean? Because you might not be necessarily familiar with it, but essentially accreditation by a professional body, which in this case is the ICHEME, the Institution of Chemical Engineers, provides benchmarking of academic programs against very high internationally recognized standards. So what this means is that essentially the accreditation can only be achieved by programs that can demonstrate very high quality training. And it's really important because a lot of the employers actually gain confidence by this accreditation. So if one of their potential employees has completed an accredited degree, the employers have more confidence that the skills that they have developed and also the level of professionalism is achieved. So accreditation is an important aspect that most of the employers will be looking for. Okay, so in terms of entry requirements for the MSc in biochemical engineering, there are 3 criteria that needs to be met. First, you need to have, as a minimum, a second class bachelor degree from a UK university, or if you come from overseas, it needs to be the equivalent. And if you're not sure about the equivalency, you can go on the UCL page on the prospectus for this program. Kim can put that link in the chat for you to have a look. And essentially, there is a tool that you can use there to look at the equivalency of your degree if you come from an overseas institution. In terms of subjects that we are looking for, as I said, we take graduates both from science degrees and also from engineering. So if you come with a science degree from biochemistry, biotechnology, molecular biology, bioengineering, or anything along these lines, that is absolutely suitable for this program. And if you come from an engineering degree, then pretty much almost any engineering degree will be acceptable for admission onto this program. We're also looking for, and this is quite important because you will be learning a lot of the engineering elements. So we are looking for evidence of numerical ability, and this can be in the form of A-levels, mathematics, sometimes, or university level mathematics, calculus, or anything along these lines. Sometimes we also accept statistics or physics as well. And then, of course, if you have relevant industrial experience, so if you have industrial experience, you are also very welcome to apply. And actually, we would like to encourage those potential candidates. But the industrial experience is not mandatory, it's not a condition of the admission. Right, so in terms of how this program is structured, depending on your undergraduate degree, you will be admitted on one of the 2 routes. So if you come from a science degree, you will be admitted on the 4 scientist route. If you come from an engineering degree, you will be admitted on the 4 engineers route. Within the 4 engineers route, we also have a pathway, which is called the Advanced Biochemical Engineering Pathway. And this is specifically for those graduates that come with a degree in biochemical engineering or in bioprocess engineering. And the idea is that through these different routes or pathway, you will be learning the elements that you are essentially missing from becoming a biochemical engineer. Right, so first route, the 4 scientists. So for those graduates coming from a scientific degree, these are the type of modules that you will have to take. So we have compulsory modules, and if you look at the list, there is a lot of engineering elements because those are the elements that you are essentially missing in your knowledge and skills. So you'll be learning about fluid flow and mixing in bioprocesses, bioprocess synthesis and process mapping, downstream processing, advanced bioreactor engineering, all of these in term 1, and then in term 2, heat and mass transfer in bioprocesses, validation and quality control. And there is a module specifically dedicated to all practicals, which is called the Biochemical Engineering Laboratory module. And then you get to choose one option in term 2. And the options that you have are commercialization of research ideas, which tends to be quite a popular module, sustainable industrial bioprocesses and biorefineries, or advanced safety and loss prevention. And of course, in term 3, you will be doing your bioprocess design dissertation. For the 4 engineers route, this is where you will be learning about the advanced engineering elements, but you're also starting to learn more about applications. So you still do downstream processing, advanced elements, bioreactor engineering, the laboratory, sustainable industrial bioprocesses and biorefineries. So now it's more about the application. You carry on with learning a bit more on the fundamental biosciences and the last developments. And then in terms of optional modules, you can choose from a variety of modules, mostly focused on applications like vaccines, biomicrofluidics, or industrial synthetic biology. And then in terms to commercialization of research, validation and quality control, or energy systems. And in term 3, on the 4 engineers route, you will be carrying out a research project. And I will be talking a bit more about the research projects and the dissertation projects in the next couple of slides. I'll give you a few more details on that. And then within the 4 engineers route, we have the advanced biochemical engineering pathway. So if you remember, this is the pathway for those of you that come from a biochemical engineering degree or a bioprocess engineering degree. And this is where you really get to focus more on the life science developments. So you will see as core modules, so compulsory modules, you get to dive in the bioprocess development for vaccines, learn about microfluidics, industrial synthetic biology, industrial bioprocesses, sustainable industrial bioprocesses and biorefineries. And of course, you will also do a bioprocess research project in term 3. Right, so some examples of dissertation projects. So the 4 scientists, you will need to do a design project, and this is actually a condition of the accreditation. So in order to fully become, an engineer, you need to learn design. Those colleagues that would have already completed an engineering degree, they would have already done an element of design. So design is really, really important because it will be a core skill for us as biochemical engineers. So for your design project, the subject varies every year, but for example, last year, the title of the design project or the theme of the design project was around adenovirus-based COVID vaccine production. And essentially different scenarios were given to different groups of students, and you had to design a manufacturing process for that particular scenario within this theme. For the 4 engineers route and the advanced engineering pathway, then those students get to do a research project. And the research projects are essentially updated every year, and they are based on the type of research that takes place within our department. So I've given you a few examples of titles of research projects from last year. And you will see they are very varied. So some of them focus on cultivated meat, others focus on more engineering aspects like scaled down bioreactors, freeze drying of COVID vaccines, some very interesting projects like traceable tissue engineering for the fashion industry, others particularly focused on computational modeling. So all of these, as I said, they covered the variety of research that we actually carry out in the department. Okay, so you've learned about the structure of the program, you've learned about the curriculum, about the accreditation, what makes it unique. So I guess now you're basically asking yourself, what will I gain from this program? Where will this take me? So first of all, it is an accredited degree, which gives you an advantage when it comes to employers, because as I said, it will essentially demonstrate the level of professionalism and the very high standards of teaching and learning that we implement. You will also get access to our state-of-the-art multi-million pounds laboratory facilities that we have within the department. And this is through the practical sessions and also through the research projects that you will be doing in term 3 for those of you that will be on the engineer's route or the advanced biochemical engineering pathway. You will get access to the modular training for the bioprocess industries. And this is through several modules. These are usually paid courses, so for external candidates, but we also offer them to our master's students and our PhD students, so you get to benefit from these. And of course, at the end of the day, all this training is designed so that it gives you the skills that you need in order to work in bioprocessing industries. And these industries can be anything from cell and gene therapy to industrial biotechnology, or even the more recent industry, which is cellular agriculture or novel foods. So I've mentioned this MBI training several times now, but I can't say this enough. It is an absolutely amazing opportunity to learn alongside people from industry, learn from people from industry, as well as from academia. And it's an absolute unique opportunity for you to build your network and meet people that work in industry. You can through building these networks, some of our students, for example, have also found mentors by attending these training courses. So yeah, if you want to learn more about the MBI courses, I've put a link here, and I think Kim can also put it in the chat. And you can go on the UCL page and essentially read all about it. You can even have a look at the type of MBI modules that are available, and you'll see those cover a range of topics, including very hot topics as well. Right, so you might ask yourself, well, where do graduates from this program end up? And this is based on a survey that was carried out over 3 consecutive academic years. But the majority of our graduates from this program have ended up in highly skilled work. A very good proportion have ended up in higher study. Wasn't meant to click that. And then if we look at a breakdown of what this means, more than half of our graduates have actually ended up working in industry, in research and development, R&D, and also in manufacturing jobs. A proportion have stayed in academia, and actually they've stayed on doing PhDs and then postdoctoral research jobs. Some went into consultancy, and actually quite unexpected, quite a big proportion went into accountancy and financial services. And some of our graduates also have gone into investment jobs as well, which it is quite unexpected. But I think this master's will give you a lot of skills that can be used not just in the obvious career paths, but also in probably slightly indirect jobs where you still need a technical background. And you know, it is a very intense program. It does require a lot of hard work and dedication from your side. And you can see some images here from the practicals. But you know, there's also a lot of fun to have, and there are a lot of social events that are organized by some of the departments. Societies, and we have the Beaker Society, which is the postgraduate society. We also have the UCL Alternative Protein Society. And actually, UCL is extremely good at extracurricular activities. And I think there are hundreds of societies. So there's something for everyone to enjoy in their free time, and you know, make friends, and yeah, essentially make this experience more enjoyable. So I would like to leave it at this. Please do follow us, and we have you know, a range of opportunities for that. And I think, Kim, we do have, which I haven't put here, but we do have a specific LinkedIn for UCL Biochemical Engineering if you want to stay in touch, and Twitter as well. We might have one for Twitter, or not. No, maybe not Twitter.
Uh, yeah, I think we best stick to LinkedIn. It's a really good environment for us, especially so many people seem to have found us through LinkedIn. So that's great. But yeah, what I'll do is I'll send an email out to everybody who registered. So you can watch this back if you want to review anything that was said. But you'll also have our details on there. You can stay in touch with us. But yeah, we post lots of our stuff on LinkedIn. I'm just going to give Petra a chance to have a look at the questions that have come through.
Yes.
Some that Petra might want to answer, some might not. But whilst Petra's having a look through what's come through in the Q&A, also in the chat, just to let you know, if you put them in the Q&A, it's a lot easier for us to answer them, and we're less likely to miss them. But we have noted one or two in the chat, so we'll get to that as well. We've actually got a series of webinars coming up, and I think it's particularly exciting this year as we're doing a couple on lab grown. So we're doing a really interesting one on lab grown meat with Travis. Is he one of your PA? One of your
yeah, he's one of my postdocs.
Yes, one of Petra's researchers, and he's doing it on can we actually make T-Rex legs and dodo nuggets, which is, I mean, it's a horrific AI generated image that we use to advertise it, but it's really interesting because it looks at the structure that you use to grow onto. And incidentally, there's a very good article about the thinnest spaghetti ever made at UCL. But it all figures in, as well as where you can extract DNA from, the quality of it, how, you know, it's a lot of interesting questions, and I'm sure you'll touch on some of the ethics as well. But we've also got a series on, we're going to be talking about vaccines, transportation of vaccines, which is as critical as actually coming up with a solution in the first place. So when I send the email out to you, I'll send you a link to our virtual taster lectures that are coming up in the spring. So if you'd like to find out more about what we do, what our researchers do, what our academics do, it's a really great opportunity to find out as we go into some interesting avenues about our areas of research. But I'll send you a link to that as well, so you can keep up in touch with us. Also, because you'll come to us through LinkedIn, you might not be actually registered with UCL, so I'll send you a link to leave your details. You'll get invitations to events, notifications, all the kind of stuff that we'd like that you might want to find out about from UCL. So do keep an eye out for that email. It'll come to you in the next week or so. Petra, I'll hand over to you, and I'll let you go through the questions as you
Oh, perfect. Thank you,
whichever order
Kim.
you want to.
Yeah, so I'm looking at the chat, and the first question is from Theo. Hi, I'm a medical professional doctor, and I am interested in a postgraduate MSc. Do I need A levels in mathematics to enter? Thank you. So that is a really great question, Theo. Actually, not necessarily. So if you are a medical professional, I would assume you would have done physics. So I can also accept physics or statistics, not necessarily A level in mathematics. And I think the fact that you already have, well, I mean, I would class it in the industrial experience, so professional experience. I think, yeah, that is definitely something that we would like to encourage more, and we will be taking that into consideration when we go through the admissions. So yeah, short answer, long answer short. Physics is also acceptable, and because you have your professional experience, that will also weight in for the admissions. But if you have any other questions, feel free to reach out to my email. Yeah, we can put it in the chat again if you haven't managed to write it down. Okay, so next question from Jean. Currently studying biochemistry at King's College London. And oh, okay. Oh, really? That's really nice. So Jean is interested in a career in alternative proteins. And essentially the question is if there are any research skills that the course expecting well, the applicants can do in this space. I currently have bioinformatics experience, but I'm unsure if this is relevant. Yeah, I mean, bioinformatics does, I think it has picked up quite a bit, and it is a hot topic now. And it does, it can be applicable to this as well. So yeah, for sure. In terms of research skills related specifically to the MSc in biochemical engineering, it depends. So if you come from a biochemistry degree, you will most likely be assigned to the 4 scientist route. So you will need to do the design project rather than the research project. But there are opportunities afterwards if you want to stay in in the alternative proteins field. We have loads of opportunities for PhD projects after your completion. And actually, if you're interested in alternative proteins, this can be a great opportunity for you to connect with the UCL Alternative Protein Society. They do a lot of mentorships. They actually can help you with building your network in the space as well. And I think now they have a project looking at the training skills necessary for the alternative proteins industry. And then compared to MRes synthetic biology course, what would be the benefit to take this course? I mean, I can't speak about the MRes in synthetic biology because I'm not the program director for that, so I'm not really familiar with the structure or the details, but the MSc is a taught program, so you do learn a lot of you do need to do a lot of modules to get the necessary knowledge, but you get access to the MBI training courses. It is accredited. And at the end, you will be at a certain level, depending on the route that you do, of the accreditation with ICME. So you can register with them as a professional member. So yeah, so I think it's really up to you when comparing to different programs. It's really up to you what you want to get out of this. And I mean, there's no, I don't know, right or wrong answer. I think it's just, it depends on your needs and yeah, your personal situation.
Just
Yeah.
to reiterate, having sat in the session with Dan yesterday, have a look at the module content and just do a side-by-side comparison, because you can see the entire content of how they're set out, and that'll give you a really good feel for it. And also just say it's a 180 credits are for the research part of the MRes. So you can see how it's a, it's a different approach. Very much up to you which one you prefer. And you can watch back the session with Darren from yesterday if you want to review any of that. But the module list is by far away the best. And also Petra has there's some great offerings in terms of optional modules for the
Yeah,
MSc. So that
yeah,
again, look at those because that allows you to provide a level of tailoring which is different to the MRes.
yeah. Yeah, I mean, every one of the programs is unique in its own way. So I think it just depends on what each candidate wants to achieve and what they want to do next after this. Yeah. Will there be opportunities for students to get experience to work in lab or in industry during the course? So unfortunately, during the course, I would say no. You get the opportunity to learn alongside industrialists through the MBI courses. And if you are assigned to the four engineers route or the advanced engineering pathway, then you get to do the research project, um, which is hands-on research in the lab. Otherwise, no, the program is very intense and it is pretty much a full year. So as I said, it does, yeah, it's quite fully packed because you're trying to learn a lot to get to the same level as biochemical engineers, but you're trying to do this in 1 year. Okay, so next question. Oh, you're welcome, Sarah. Thank you for attending. Okay, so I can't see any more questions in the chat, but I think there are some questions in the Q&A. Oh, and I see you've already answered some. Right, so how does a design project differ from a research project? Yes, that's a really good question. So the research project is essentially hands-on experience in the lab. You get to do things in the lab. There are different projects, because actually I'm thinking now all of them are lab-based. So for example, those that are kind of computational modeling, those will be desk based. They might require some experiments in the lab so that you can get some experimental data to actually validate your models. But the majority of other research projects will be hands-on in the lab. In terms of the design project, this is where is very much paper-based, desk-based. You will be working in groups on a given case study or a case or a scenario within a theme. So you know how I've given the example of the COVID vaccines, that would be the theme, and then each group would get specific scenarios. You might, I don't know, you might be given the actual cell line to work with, you might be given the scale to achieve or the number of doses that you need to achieve. And essentially you have to go through all the steps of designing the manufacturing process. So you get to pretty much apply everything you've learned through the other modules, which they have prepared you to this stage of the design project. And the design project is linked to a couple of the MBI training courses as well. Okay, so hopefully that answers your question. Are there any other questions from anyone?
Just to let you know, we've booked out until the hour, so we're available for you for the next 15 minutes to answer any questions you have. I'll just let you know in the Q&A box. You can post anonymously if you wish, if you want to use that function. But if we don't have any more questions, we're happy to wrap up if we've covered everything. And also, just to reiterate, if there's anything you think of afterwards, you do have my email address. Please get in touch, and I'll be more than happy to put you on to the right person, or answer it myself, or pass it on to Petra, whatever. Yeah, so we're coming up to quarter two. I think we've gotten through all the questions. So apart from that, we do Actually, oh, yep, somebody said, asked if they can ask another question. By
Oh
all
yeah,
means,
of
yes,
course.
that's what
Yeah,
we're here
yeah,
for.
yeah. Go for
Whilst,
it.
whilst
Yeah.
you're typing that question out, I think I will let you know that on the, I think it's towards the end of January, you'll get a notification about this. We're actually going to have a panel discussion with Petra, Darren, and Rana, who are our postgraduate program directors, and they're going to be talking more in general about UCL biochemical engineering, our unique facilities, our research activities, to give you an idea of what we do and what kind of an experience you can have as well. So that's something that's keep an eye out for that because it should be really interesting. And rather than focusing specifically on the program, it'll talk to you about the kind of things that we do, especially as a as a prospective postgraduate student that you might be interested in taking part in and going a bit of a deep dive on what our activities are. So just waiting for that question to come in. I don't know where it's gone. Just actually one thing which occurs to me is Petra. I think it might be worth talking about the. Oh, here we go. Ah, okay. Somebody's asked. Actually, just asked about. Actually, Petra, I'll let you read this out. It's a really good question.
So what kind of research going on in UCL? Oh, okay, in alternative proteins. Um, yeah, I mean, I am leading on the alternative proteins research. I actually founded the UCL Cell Agriculture Research Group since I started at UCL, and we've been really growing over these last couple of years. But we have projects from the Cell Agriculture Manufacturing Hub, CARMA, which is a consortium of universities in the UK. So it's led by University of Bath, UCL, Aberystwyth, University of Birmingham, Royal College as well. Karma is all about developing manufacturing processes that are sustainable, environmentally friendly, for manufacturing alternative proteins, particularly cultured meat, and also looking at palm oil replacements, because there are a lot of problems with that. So that is one. Within the Karma, it's actually myself and also Professor Gary Lai. So both of us work and have projects within Karma. So I focus more on cultivated meat research. That is my specialty, my expertise. Professor Gary Lai's expertise is more in precision fermentation. So we've actually recruited quite a few PhD students and postdocs to work with us on various subjects, from manufacturing processes to manufacturing fat only as a component of cultured meat, to media development, to downstream processing, and looking at various unit operations. So that is one part of the research we have. We're also involved in the Bezos Earth Fund that was recently funded. So the Center for Sustainable Proteins, that is led by Imperial College London. And that's actually quite a new initiative, and quite big as well, because it has so it comprises a lot of universities and entities within UK, but then it also has, the Bezos Center, Bezos Earth Center. But it also has links with Tufts University, Professor David Kaplan in US, and also with A-Star in Singapore. So as part of the Bezos Center, we are actually going to be recruiting soon, probably in about 3 months' time. We'll be recruiting postdoctoral researchers on this project, so definitely keep tuned to our LinkedIn page. So a lot of the projects, especially in the cultured meat, are from manufacturing to differentiation, serum-free media development, What else? I'm trying to think because we do a lot of things. Oh yes, edible microcarriers. We also look at those. So essentially, it's all about manufacturing and the tools and ingredients that go into manufacturing. That's what where my interests lie. Yeah, so hopefully that answers your question, Jean. But if you do have any more questions, my email address, and I'll write it in the chat as well. So feel free to reach out at any point. Very happy to answer any other questions.
And somebody's actually put a question saying that they come from a microbiology background. They're a microbiologist and asking whether, I guess that would
Yeah,
put them on a specific on which pathway would that be?
yeah, so we've definitely had graduates from microbiology in the past. It is a science degree, and yeah, it's suitable for admission on this program. You would be assigned to the force scientist route in this case. You just need to demonstrate or have something to demonstrate the numerical ability. So as I said, A levels mathematics or a university level mathematics module or, statistics, which probably you would have done as part of your microbiology degree. Yeah, chemistry as well. Yeah, we've had candidates from graduates from a chemistry background as well. The same applies for you, yeah, with the numerical ability. So chemistry, biochemistry, biology, microbiology, molecular biology, biotechnology, bioengineering. I'm trying to think what so anything along those lines, yeah, these lines, it's appropriate for admission on this program.
Wow, there's some great questions there. Thank you very much. Okay, I think we've wrapped it up there. So I'd like to
Fantastic.
thank you very much for joining us today. It's been great to have you with us. Thank you very much for those questions. Very interesting. Kept us on our toes. Really good. And thank you, Petra, for joining us. It's been a great session, and I hope to see as many of you as possible in person at UCL in the future at some point. Until then,
Thank you, everyone.
thank you very much. Have a great day and have a great week. Bye bye.
Take care. Bye bye.